Next topic is equation of motion of a rigid body rotating about a fixed axis. First of all, we consider a body that is a mass of rotating with an axis of axis that is radius of r and center as O. So we are considering, first we are taking an elemental body, the elemental mass, that is dm, for a total mass. If this is a total m, if you are considering m, this is a elemental body, that is dm. So for that purpose, we know that the acceleration is alpha and velocity is omega and the displacement is theta. So we know that acceleration is equal to, that is tangential acceleration is equal to r into alpha. We already discussed about these derivations and all other things. So we know that F is equal to ma, thus force is equal to mass into acceleration. Fourth, we are applying the same thing here, that is tangential force equal to mass into tangential acceleration. Instead of this, because of tangential force this is, so we are using tangential acceleration. So mass is dm because elemental mass. Tangential acceleration we have already discussed about that, r alpha. So dm r alpha. So what is moment? Force into distance. So force, what is force right now? That is dm, that is we are taking moment about O. So force is dm alpha into r. Distance is, this is the distance, that is 0 from O to dm, that is radius r. So the moment about O, dm alpha r into r, so it's alpha square, dm alpha r square, sorry, alpha, not alpha square, that's r square. So next thing, for considering, instead of right now we are considering the elemental body dm, for considering the total body m, for that we are integrating this equation and then we will get the turning moment T is equal to integral of dm r square alpha. So we get that integral of dm r square, that is second moment of inertia, that is I. We already discussed about this I and all other things in previous chapters. So we substitute the value of I, so therefore T is equal to I alpha, because this portion is I. Okay, so this is a very important equation, so just note down. Then next portion, next topic is kinetic energy due to rotation. We know that kinetic energy, that is K, that is half mv square. Here instead of m we are providing dm, that is elemental force, elemental mass. So b, what is b? That is r into omega. So we are substituting the value of, instead of v, that is r omega, so that is 1/2 dm r omega square. We are then square is inside, that is r square omega square. Then for considering for all bodies, instead of elemental body we are considering all bodies, so we are integrating that thing, that's integral of 1/2 to dm r square omega square. So here also I is equal to, that is a second moment of inertia, that is equal to second moment of area, that is equal to integral of dm r square. So we are just substituting the value of the, so we get that K is equal to 1/2 I omega square. The next thing is work done in rotation, that is work done is equal to T theta. T is torque and theta is a displacement. Is displacement, we can take that in rotation, that is 2 pi n by 60. We are discussing about what is 2 pi n, already discussed about in previous lectures. So we are substituting the value over there, then we can get that work done is equal to 2 pi n t by 60, that is in watts. The next topic is work energy equation for rotation, that is T is equal to I alpha, that is we already know that. Instead of alpha, we know that the derivation for the alpha, we already discussed about that thing in previous lectures, that is alpha is equal to d omega by dt. Instead of d omega by dt, we are substituting d theta and d theta, then d theta by dt we can convert to the omega. We are substituting this thing here, so that is I instead of alpha omega d theta. The d theta we can substitute here, we can take that this side, so t d theta, that is equal to I omega d omega. So we are integrating these both sides, that is 0 to theta t d theta, that is equal to integration of initial to final velocity I omega d omega. then we will get that instead of the d theta, we are integrating by up to theta, that is we will get that theta, and then we get integrating omega, that is omega square by 2, the limits of initial to final omega square. Then that is equal to, we are substituting the limits, half into I omega 2 square minus omega 1 square, that is equal to, that is we are substituting the inside, take inside, and half I omega 2 square minus half I omega 1 square. But is this one, that is half I omega, that is kinetic energy. This one is also kinetic energy. So this is final kinetic energy, this is initial kinetic energy. So what is the difference between these two? That is change of kinetic energy. So we can write this as work done is equal to change of kinetic energy.